Hi everybody, welcome to another section in trigonometry, section 2.2, solving right triangles. Before we actually go to any trigonometry, just go over significant figures or significant digits. This is very important in science, in particular chemistry and physics. Right, so the rules of significant figures. Number one, the digits 1, 2, 3, all the way to 9 are always significant. So that's the first point. Those are significant. Next, the leading zero are not significant. So from 1 to 9 is easy. All of them are significant. The problem is that the leading zero, not significant. The first non-zero digit on the left is significant. So that it's the 1 to 9 thing again. 0 between two non-zero digits are significant. So yeah, there's just one rule for everything else, and the zero, there are 3 different rules. Leading zero are not significant. 0 between two non-zero digits are significant, and then the 0 on the back. The trailing zero considered significant only when the number contains a decimal point. So there are 3 rules for 0. Leading 0, not significant. 0 in between, always significant. 0 on the back, depends if there's a decimal or not. Right. So let's look at this example. Determine which of the following numbers are significant digits. I'm going to underline those significant digits. First from 1 to 9. So this digits 1, 2, and 3 are significant because not 0. That's easy. And the 0 in between two non-zero are also significant. So this 0 is significant because it is between two non-zero. So there are 4 of them. 1, 2, 3, 4. And then the trailing 0 does not count because there's no decimal point here. So this 0 does not count. So this 2 not significant because there's no decimal point. So only 4 of them significant. This 0 are not significant. Next, we have this example. 0.012050. Right. First of all, the leading 0 are not significant. So those 2 are not significant because leading 0 never are. And then we have the 1, the 2, and the 5 here. Definitely significant because not 0. The 0 in between here also significant. So I mean we have 1, 2, 3, and 4. How about the last 0 here? This is the trailing 0, but because there is the presence of the decimal point, that number, that 0 is also significant. This one also significant. Because it is, after there is the decimal point, that number 0 after decimal point is significant. Any trailing 0 after decimal, any trailing 0 with the presence of the decimal point is significant. Right. Next, these 2 obviously significant. This is the trailing 0 because there is the presence of the decimal point. Even though that 0 is in front of decimal point, doesn't matter. If there is a decimal point, any 0 after that is significant. So this 0 is significant because there is the presence of the decimal point. Whether the number 0 is be after the decimal point or in front of decimal point, any trailing 0 with the presence of the decimal point is significant. Right, so that is the rule for numbers, each number. Right, and my question is, let's say if you have like the number 13000 and you want to write this with 4, let's say if you want those 4 numbers to be significant, then how do we do that? Well, the way we do this is we have to write this in scientific notation, and then we write 0. So this 0, there will be 4 significant figures. Let's say decimal 1 2 3 4 5, so that times 10 to the 5th power. So if you want to write this 123000 with 4 significant figures, use scientific notation, then you can say there are 4 of them significant. Right. Now the operation. Now we know each number, if it is significant, how many of significant digits in each of them. Now multiply dividing numbers that are approximation should be rounded to contain the same number of significant digits as the number of the fewest significant digits. So let's say if we do this numbers, let's do the math. Right. So we have 1.2. I will underline all the significant figures or significant digits. There will be 1, 2, 1, 2, 3. Just put the books here so it's kind of zoom in. Right. So then I just use a calculator. 1.2 times 32,500. Right, I have 39,000. Yeah, and the result, we have 2 significant figures and times 3 significant figures. We round it to the one that with 2 significant figures. So this is perfectly fine. 39,000, 2 significant figures at the result. 2 significant figures. Right. Perform this. Now we add them. Now when add or subtract, the number that are approximately should be round to the last digit that is significant in both of them. So let's write this as 3.205, and we add in column 1, 2. Right. So we add them. It's easy. That will be 1, 5, 7, 0, 5. All right. Now the rule says we should round them to the last digit that is significant to both, and this is the last digit that is significant to both of them. So this problem we should have keep those 3. So the answer is, for this, it's going to be 15.7. We round that to 15.7 because 5 is the last digit that is significant to both. Now we divide 123.5 divided by 47. This is equal to 2.62766. Let's say that. But because there are 2 digits in one of the 2 numbers, so the answer is we round to, the answer only take 2 significant figures only, because one of the 2 number only have 2 significant figures. So it's 2.6. Next, 1000 minus 12. Right. So that gives us 188. However, remember, this is not significant, not significant, not significant. So when we add them, we don't round that to those values at all. So the answer is just 1,000, because this is significant. And you say, if we write 0, 0 here, that's not significant, right? But no, in that case, that will be 1,000, because this 0 is not significant, so we cannot just say 988. It is not significant here. If there's a decimal, then those 0 are significant, then the answer is 988. But if this is 1,000 and those 0 are not significant, then we just have 1,000. Right, so that's just the way it goes. However, that's nice and all, but in the focus of trigonometry, do not focus much on that, because like I said, the science, they more worry about this. But in math, assume that all our calculation, we can carry all the decimal places, as many as we want to. So that's the spirit. So in that case, so the calculation should be exact. So we're not worried too much about this. Besides, my math lab homework, usually if there's a rounding, they will tell us round to how many decimal places they want. So they keep in just number of decimal places is a lot easier than to say significant figures, which is a little more difficult concept than just say how many digits after decimal you will take. Right, but in terms of calculation, we keep every calculation and we only round that at the end, even though we might write the answer on the paper, but at the end, all the calculation will be kept in the calculator, and we only round at the end answer. Right. Now we go to more focus on the trigonometry now. Solving right triangle. Solving right triangle is to find all the missing length and the missing angle of a triangle. This is the right triangle, so we know one angle is 90 degrees already. So later on, we will solve for right triangle in the general sense. But for now, let's just draw a triangle, so we have a better sense of what are we dealing with. It is the right triangle, so we just could give the angle, let's say it like this. Right, there's the right triangle. C is the right angle, so there's C. Angle A, it doesn't have to be exact 32.7. We just draw a triangle, the right triangle, so we get the idea of the relation between the sides. Right. Angle A we know is 32.7. Angle B we don't know. C is opposite to the sine C, 14.3. By the way, the angle C and the sine C, for the angle C, let's just say that is a capital C with the little curly on the head. Right. So solving right triangle, meaning that we find all the missing information, meaning this angle B, this sine A, and this sine B. Right, so we find all the missing information for that right triangle. Right, so what can we find? Right, first thing first, in the right triangle, or in the triangle, all angles add up to 180 degrees. So if we know one angle with the right angle, so that 2, we can find the last angle. So that will be the first thing I will go with. A plus B plus C is 180 degrees. So angle B will be equal to 180 minus A minus C. So 180 minus 32.7 and 90 degrees for angle C. Right. (180) minus 32.7 minus 90, so 57.3. degree. So we found angle B. Now we know angle B. How do we find A and how do we find B? Right, there's a few different ways. Now, trigonometry we can use based on the angle A, or we can base on angle B. However, if we have a choice, we will use angle A instead of angle B. The reason being, angle A is what is given. What is given is a lot more accurate than what is calculated. Because in the calculation, we might have some rounding error, right? So, whatever the numbers whatever the calculation we use, it will be best if we use what number that is given from the prompt. Unless we have to, then we have to use the number that we calculated. Right, so that's the spirit of things. Right, now, again, we are given are those. Now, let's say we found angle B, which is good. Now, let's find A. So, with respect to angle A, this C is the hypotenuse. With respect to angle, actually, it doesn't matter, because that is opposite to angle C, hypotenuse opposite to the right angle. And with respect to angle A, little a is opposite. Right. Then they ask you what ratio that has opposite and hypotenuse to it. Okay. Oh, I thought I'd write that on a piece of paper, but nope. I only write this. Okay. So, with respect to angle A, we have opposite over hypotenuse. So that means sine of 32.7 degrees equal to opposite. We know opposite is 14.3 inches, but we just left the unit out for now. Over. Okay, be careful. This is not difficult. Just always have to be careful. So we have opposite, which is A, over hypotenuse, which is 14.3. Right. Of course, if we write fraction cross multiply, so little a times 1 is equal to 14.3 times sine of 32.7 degrees. We'll type the whole thing like that. So, before we do any calculation involving trigonometry, make sure that it is in the right mode. So it has to be in the degrees mode because we have degrees. Right? So 14.3 times sine of 32.7. Yeah, so make sure it is in the degree mode. So we have 7.7, and the unit is inches. Right, this problem did not say round into decimal places, so we just going to keep one decimal places. How about that? Right. Now we have A is 7.7. Now, next, so we have angle B, we have little a, now we have sine B. So how do we find sine B? Now, knowing the hypotenuse, knowing one side A, we can find B using Pythagorean theorem, right? Certainly we can use Pythagorean theorem. However, that brings up to the point that I mentioned before. If we have a choice using what number that are given is better than using what number we calculated. This number we calculated. So I still prefer to choose the number that are given. Now, if with the information given with respect to angle A, B is adjacent. So we have adjacent and hypotenuse and angle A. So that is cosine is adjacent over hypotenuse. And cosine of 32.7 degree. Adjacent we don't know, but that is B. And hypotenuse we know is 14.3 inches. Again, I left out the unit. Yeah. So those numbers are given, 32.7 and 14.3. Those are given. I prefer to use those over the number that is calculated. But then again, if we know A, we know C, Pythagorean theorem will work just fine to find B. If you carry a bunch of decimal places and only round at the end, then that's still fine. Once again, if we use Pythagorean theorem, we have to carry a lot of decimal places and only round at the end. Because if we use this number, I'm not going to use 7.7. I'm going to use 7.72546. I've used about 5 or 6 decimal places here. Or I can use the whole thing. So I can just take that number square plus B square equal to C square. So in fact, what I would do is 14.3 square, that hypotenuse square, minus that number square. And then I take the square root. When you highlight the number, hit enter and like copy and paste. So the answer will be 12.0. Yeah. So in that case, yes, that will work if you use the whole numbers. Do not round off anything. Only round at the end. Right. Now if we use this, then we don't have to worry about the rounding thing. So B times 1 is equal to 14.3 times cosine of 32.7 degree. So 14.3 times cosine of 32.7 degrees. As you see, the numbers will be very good. So don't round anything in the middle and use those numbers. Use the whole thing before rounding. So B is equal to 12.0 inches. Yeah. So use the number that are given will be better than use the number that are calculated. And if you have to choose the number that you calculated, use the whole number. Use as much decimal places as we have. Right. Let's look at another example of solving right triangle. Okay, let's look at this one more time. So I'm just going to draw a generic triangle and then put in the information in, so we know what we don't have and what we have. Right, solving right triangle. Once again, I just put a triangle. This is the right triangle again, so yeah, kind of generic triangle. Generic right triangle. C is the hypotenuse, therefore C is the right angle. Big C is the right angle. Little a, okay. Yeah, I can just choose one of them to be A, the other one is B. So once again, let's say A is here and B is there. Alright, what we know is little a is 18.91. centimeter. This is A, little a. And little b is 21.48. And what we don't know is C, the sine C, the angle B, and the angle A. Right. So there are a few things we can do here. So first, we are given A, we are given B, the right triangle. Pythagorean theorem will work just fine. Basing on those two numbers, Pythagorean theorem will work just fine. So Pythagorean theorem, A squared plus B squared equal to C squared. So A squared is 18.91. B squared so C will be just square root of that. So I will type everything, just type the whole thing in, the whole numbers in, as will be better than you do the square first and then take the square root later. So 18.91 square. Whenever possible, do this. 21.48. Yes. Rather than do this first and then take the square root, I type everything in one step, if it's possible. So 28.6. Right. So look like all of them has two decimal places. So why don't we just keep two decimal places here? Right. So 28.62. Right, two decimal places. Unit, centimeter. Right. So that is C. Right. If you pay attention, then you say, why don't we put the parentheses here and why do we don't put the parentheses there? It's just a way I learned in grade school, because in this side, the left hand side doesn't have the unit. So it will be wrong if we have something that doesn't have unit equal to something with a unit. If I'm going to write this by itself like this, it's fine, because we don't have a number on the right side that doesn't have the unit. So keep things balanced. So I'm not going to say a number is equal to something with a unit in it. So this doesn't sound right. But if you write by itself like this, it's perfectly fine. Right. That's just little things that I was taught a long time ago. Anyway, so now we go with angle A and angle B. Right. Now, there's a lot of different way to do this. Since we know C, we can use hypotenuse, opposite, and adjacent. However, just like the last one, we try to use the number that are given as possible. So let's say with respect to angle A, we have the little a, which is opposite, and B, which is adjacent. With respect to angle A, we know those two information. Now, what ratio that have opposite and adjacent? That could be tangent, right? So tangent of A is equal to opposite over adjacent. So I will say tangent of A equal to opposite 18.91 over adjacent 21.48. Right? Now if tangent of A is equal to that, then A is inverse of this ratio. So once again, I'm not going to enter the ratio first and then to the tangent inverse. More important, when we do the inverse, make sure again the calculate in the right mode, in the degree mode. So tangent inverse, type the ratio as possible because those exact number that are given. Divide by 21.48. And it's 41. Let's use 1 decimal places or 2, it doesn't matter. Let's say 2. Yeah, in the homework it will specify how many decimal places they want. Right, so that's good then. Next, find angle B. Once again, I'm still using those two numbers if it's possible, right? Now, different perspective though. With respect to angle B, this is opposite and this is adjacent. So tangent of B, again we have opposite and adjacent. So different perspective. So tangent of B, opposite to angle B is 21.48 and adjacent is 18.91. So B will be tangent inverse of that. So B equal to tangent inverse of this ratio. Right, tangent inverse of 21.48, opposite divided by adjacent of 18.91. And it's 48.64. Right. Now, actually, since we know C is 90 degrees, angle A is 41.36, add up those two, subtract from 180. A plus B plus C is 180. So knowing the angle, the right angle, and one acute angle, we can find the other. But then again, this angle is calculated. I prefer not to use it. Right? So I still use the number that are given when possible. That would be nice. But on the test, if you're stuck and then you don't know how to do that, just take 180 minus 90 degrees, for sure that's the right angle, and then minus the 41.36. You will use this number because that is the more accurate number than 41.36. So we subtract those numbers, and you see those are identical. So once again, preferably you might want to try use the numbers that are given. That will be best. If we cannot do that, use the number that we are calculated, but use all the numbers before we round it. Right. So let's look at some application. Angle of elevation and angle of depression. So angle that are measured between the line of sight and the horizontal line are called angle of elevation and angle of depression. So let's see. If we look it up, to restore, compared to the horizontal line. This angle is the angle of elevation because we're looking up. Now if we look down, and compare to the horizontal line, this angle is the angle of depression. Right. Now let's look at an example here. A girl is flying a kite. How long of a string must have to raise the kite 200 feet above the ground if the angle of elevation from her eyes to the kite is 25 degrees and her eyes are 5 feet above the ground? Right? So let's just sketch what we have here. So first of all, we have the ground. Assume that it is perfectly flat and perfectly level. Those are the things that we have to assume when we do this kind of calculation. So those are the ground. This is the ground. Right. So a girl stands flying a kite. So, and let's see, at this is the eye level, and the kite is the angle of elevation is, and suppose, I mean it depends where she hold the string. Let's assume that she hold the string right on the eye level, which is 5 feet off the ground. Yeah, suppose she hold the string about the eye level too. So that with the assumption. And this is, we'll make the angle of elevation is 25 degrees from the eye level. The eye level will look horizontally parallel to the ground. So this is the eye level, horizontal eye level. And the kite is 200 feet above the ground. The angle of elevation from the eye is 25 degrees. So this is the string, and the kite is right here. And also assuming that the string doesn't have any weight, so this is perfectly straight. Of course, usually when you fly a kite, it kind of some lag of the string, but let's assume there's no lag either. And the kite here, let's say it is butterfly. Right. And that is 200 feet above the ground. And of course we assume that this are right triangle. Right, this is what we have. Right, the question is, how long is the string? So let's say this is x. We don't know the length of the string. Right, so we have the right triangle. Also, we know that it is 25 degrees of the angle of elevation. Now, this is 200 feet and 5 feet at eye level. So the difference of them is 195. So we have to find the difference between this actual side. So that is 195 feet. Now we have a right triangle. With respect to this right triangle, we have, with respect to 25 degrees, this 195 feet is the opposite, and x is the hypotenuse because it is opposite to the right. It is opposite to the right angle. So we have tangent of 25 degrees is equal to opposite over hypotenuse. And that will be totally wrong because opposite over hypotenuse is sine. Right? So sine of 25 degrees equal to opposite over hypotenuse. Opposite 195, hypotenuse x. Again, write a fraction, cross multiply. So x times sine of 25 degrees is equal to 195. So x equal to 195 divided by sine of 25 degrees. Right, degree mode, which is good. 195 divided by sine of 25 degrees. Yeah, so that's correct because it will do the sine first before it take 195. If you're not sure about it and one absolutely sure, hit alpha y equal to. If your calculator can do this, then there will be no confusion here. So that's 461 feet. Yeah, let's round to the whole number. 461 feet is the string. So that makes sense, right? If it's 200 feet and the string have to be a lot longer than that. So 461 feet sounds correct. Right, next. Another example. A forest ranger in a fire tower 30 feet above the ground see a small fire. The angle of depression from the ranger to the fire is 21 degrees. How far is the fire from the base of the tower? So, in this case we have a tower. So, and this is 30 feet above the ground. Feet. He sees a small fire. Once again, we assume that the ground is perfectly horizontal, and the forest ranger sees a small fire. That is, the angle of depression is at 21 degrees from the ranger to the fire. So, assume that he looked horizontally compared to the horizontal line. The angle of depression is 21 degrees. And the question is how far from the fire. So the fire is here. How far of the fire from the base of the tower. So we will we are asked to find this length. Right. So now once again we will form a right triangle. If this one 21 degrees, this add up to 90 degrees. So 90 minus 21, 69 degrees. So we can see that this is 69 degrees. Also, this angle, those are alternate interior angles. So this is also 21 degrees. So we know those two angles. We can use either one of them. Right. So let's use 21 degrees because that again is given, and those two are equal because alternate interior angle. So they should be equal. Right. Now, the 35th is here, which is opposite, and we know opposite. So we have the opposite, and x with respect to what 21 degrees is adjacent. So with respect to 21 degrees, opposite is 30, adjacent, don't know. So we will say the ratio that is opposite over adjacent, that is tangent. So tangent 21 degrees is opposite over adjacent. Right. So we have tangent of 21 degrees. Opposite we know is 30. Adjacent we don't know. Have the ratio, cross multiply x times tangent of 21 degrees equal to 30. So for x, 30 divided by tangent of 21 degrees. That is 78. That's two 1 decimal places. Like I said, on the homework on my math lab, it will specify how many decimal places they want. The same thing on the test. Right. So basically, this section solving a right triangle. So we are given some information about the right triangle. We just find the missing information. And in terms of calculation, it would be better if we use the number that are given. If we have to use the number that we calculated, use the one that with all the decimal places in the calculator. Do not round any step in between. Only round at the end for the answer. Right. So with that, I finished section 2.2. See you in another video in trigonometry. As always, thank you for watching.